In 1927, German physicist Werner Heisenberg developed a key theory that would revolutionize quantum physics. This theory is known as the principle of uncertainty. Uncertain about what this principle exactly states, I'm here to help. To begin, let's get a profound understanding for basic physics and the law that govern our universe. We exist because of matter. It's what composes our bodies and everything around it. A particle is an object with mass. Particles can move around. Hence, momentum is relevant in the manner that the universe moves. To find an object's momentum, you can multiply its mass and its velocity. Of course, you may be thinking, well, it technically is possible to find an object's momentum and relative position, per se a car. You can find how fast it is moving based on the speedometer, and also find where it is located. But according to the principle of uncertainty, this is not the case. So how does this work? That is the case only because the very small masses of atoms or subatomic particles that do in fact make this principle significant aren't taken into account. So let's move on to a much smaller dimension. This is where H comes into play. When we do, however, integrate them and observe them, we realize that only for these very small masses do the uncertainties become significant and actually true. Far beyond that, however, particles also have wavelengths associated to them. These waves correlate with its momentum. A particle's position will be near the top or the bottom of these waves, where it is most intense. By studying these waves, we now realize that there can be a measurement for position on the particle, but its velocity is unknown. So for example, this ball beam. Once in the video, we can tell it has momentum. Through series of calculations, we'll be able to determine. Let's try pausing the video, however, and you will see how it has some blur to it. Its position is not exact because it is constantly moving. If we were to take a precise snapshot and keep it still in the time, we would be able to pin the location, but we would not necessarily know if it is moving at all. On the other hand, if we try finding its velocity, its position could be anywhere. If we look at all this in terms of numbers and calculations, we also see how this principle is supported. Delta x, or position, times delta p, momentum, is always greater than equal to h over 4 pi. This is true in life, because almost everything we encounter is greater than h. H is a very small number, small subatomic particles, for example. But once we get to h small, the uncertainty principle rule kicks in. Because according to this rule, the equation must always be true, so in order to stay that way, it's nearing the edge at almost making the equation false, so that delta x will change, or that delta p will change. With momentum and position, energy and time are associated. Moreover, both energy and time play somewhat of a role in this principle. Therefore, in essence, the uncertainty principle states that you cannot know both the position and frequency, and can only determine one or another. The position or where you are and the frequency or where you are going cannot both be determined.